Quarkus Insights, Fundamentals and Principles with a special guest, Jason Greene. Fundamentals and Principles with a special guest, Jason Greene. Somebody has a full feedback loop. Hey everyone, welcome to this new episode, Quarkus Insights. Please tell us how we do. You know, I don't know how many have seen 12 episodes, how many have seen 11, how many have seen 13. You know, who knows? That'll be interesting to know.
There is 13. We started at 0. We started at 0.
Oh, I forgot about this one. Yeah. One of those clever things you forgot. So today we're 4. Like there's me, Emmanuel, Georgios, and Max that you're familiar with. And there is somebody else. Yes, Jason.
Hello, everybody.
So, Jason, for people who don't know you and your relation with Quarkus for some reason, can you tell us a bit about you?
Sure, yeah. So, some of you might recognize me from Wildfly. Previously, I was the Wildfly project lead. And then a few of us had this really crazy idea to revolutionize Java for cloud. And we came up with Quarkus, and that's kind of been a huge journey for all of us. By the way, I'm getting a bit of a feedback.
Yeah,
as well.
Max was playing. By the way, Max, there is your name, and then there is your name. So stop overlaying.
Double.
Yes. So today is a bit of a special episode because if things go well, there'll be no code. No presentation, of course, never do presentations in a slide deck. But we're going to talk about the why of Quarkus, essentially, the foundational principle we try and run the community from and where we want to go, all right? But before that, a little bit of news. So there are... yeah, there you go. There is a couple of news that are really noteworthy. Of course, always go to the blog. It's where you see the most interesting one. The first one is Quarkus 161 has been released last week. Georgios, do you want to tell us what it is?
Yeah, well, basically it's like a bug fix release, right? So we had a lot of bugs fixed, probably like, I don't know, 30, 40, maybe more. There were some that like we didn't have time to get into as 160 final. Then there was more based on the awesome community feedback that we got that we fixed. So it should be a lot more stable. And basically it also ties into this other theme that actually you announced on the Quarkus dev mailing list, where we're asking folks to like actively participate in a bug hunt so we can make like 1.7 as stable as possible. So if you see like there's a lot of bugs that we fixed, but we really want to fix more, right? So it could be like even small doc issues or whatever. So if anyone like wants to participate, and we're here to help out, here to test things for people, and make sure like anyone can contribute as much as they want, as much as they can. That'd be awesome to see.
Yeah. I think it looks like more than 40 actually.
Well, some of them are like PRs. Well, there's both PRs and the issues in there together. So yeah, there's a little duplication there.
Okay, it's just 812 commits. It's all you need.
Yeah, like anyone who watches Quarkus can see that like we move really, really fast, right? Yeah. So there's always a ton of commits in there.
The other stuff. So
you know what?
Yeah, go ahead, Jason.
I was just gonna say, you know, if you guys are checking Quarkus out and you're kind of not sure where to start, you want to contribute, but you're not sure where to start. Just like this is one of the best ways. You just take like a bug, even if it seems like hey, this is going to be really easy. It's just a few lines of code or whatever. That'll get you through the whole thing. You know, you'll go through how you get your PR in, how you get it reviewed, how you get submitted, and then it's really easy to just kind of scale up from there. So, great way to start.
Yeah. The other thing, I don't know if we discussed it last week, but it's probably worth saying it twice. Quarkus now support the notion of test profile. And what is a test profile is essentially a way to configure Quarkus differently between some tests. So initially, until that feature, you were configuring Quarkus, and there was the test profile, and every test we're running with the same properties of the test profile. But in some situations, you want to mock some specific beans, or you want to override some specific properties to behave a bit differently and have a better test coverage. So we've created this interface, Quarkus test profile, that you can implement and pass over your tests. And you can literally override, so not replace, well, it's taking the existing configurations, but then you add, whatever additional configuration or overriding all the existing configurations you want. You define the profile. So profile is the test profile or whatever custom profile you want, like, test with local database or something like that. And then this one, it doesn't sound like much because alternatives is a weird name, but it's a cool feature of CDI, which enables you to replace essentially a bean implementation by another one. And here you can literally essentially decide, I want to replace this with a mock version of it, and then have your test running. There's one important aspect is that you need to, it's better if you sort your tests so that the one that requires a specific test profile, Quarkus test profile, are really in the same alphabetical order with a fully qualified class name. Because every time we see a new test profile, we stop Quarkus and restart it. So it adds not a lot, but a tiny bit of extra overhead. So it's better to do it as little as possible. And that's all the news we had. Stuff keep going. 1.7 is on its way. And I guess we're ready to discuss the fundamentals. Please ask us many questions. Challenge Jason, and we'll help you, beat him to the side.
I just want to pick up on something you just said, which was just a second ago. You mentioned that anytime a new profile is added, test profile is added, the system gets restarted. And it's just the funny thing about that is that not that long ago that would be a ridiculous concept, right? Like, oh, we'll just restart the whole thing, because restarting the whole thing used to take 30 seconds, 60 seconds, right? Yeah. So it's just sort of interesting, like, to how crazy we can push this technology, in all these different applications. It's like, oh, well, we'll just restart the whole thing. It only takes a few milliseconds.
It reminds me of when I moved from SVN to Git. Right? It's the same thing. Yes. But suddenly it's
like,
can
why
merge.
do you need it? It's like, why do you need distributed, SVN? And then people that were already on the other side of the fence were like, just do it, you'll see. And then you were all fun. It's like, no, I think Mercurial is better anyway. And then in the end, it's like, all right, Git was good.
Speed matters.
Yes.
Well, yeah. Speed and ease of use, right? Because some users tried to do this stuff like hacking like parts of the application or whatever, but now with Quarkus you don't have to do that. You just don't worry about it, and it just restarts so quickly. So it's also speed and matter and ease of use.
But before we go, let's get ahead. Maybe Jason, you want to say where did Quarkus come from? Because you and Emmanuel is kind of part of the. What's it called? Primordial soup before there was anything called Quarkus?
It came from a boring meeting. No, I'm kidding.
Like, make Java fast?
There was no, we cannot say that meeting, what it was about, but that was like a tough meeting rather. And we said we need to rethink entirely how we go address that problem. But go ahead, Jason.
Yeah, so I mean, one of the things is I think a lot of us have had different ideas in this realm for how we could really innovate, and I think what the big thing that it just that ultimately happened is we just a set of different problems kind of collected together, and we're like, hey, we could actually take a fresh approach at this and really address all of them at the same time. So like the biggest one, of course, is just and you really started to realize it when you're taking Java technology, which was some of the most productive. Actually, I'll jump right into like a question I get every once in a while, which is, hey, why should I use Quarkus? Instead, I shouldn't just use some other completely different language to run on the cloud. And the reason is because Java has if not the most, one of the most productive development environments that you could use, both for, in terms of tooling, frameworks, the whole declarative paradigm when you work with annotations. So like from a developer's perspective, Java is awesome. And it's also awesome running on bare metal. It's great. But then what ended up happening is, containers come into the picture. And there's just this impedance mismatch between Java technology, which is all about like dynamic hot updates. I can instantly change my app server on the fly. I just got to throw this jar in, and then it rediscovers the world, and a bunch of classes are dynamically generated, and boom, magic happens. Except you put it in a container, and they're immutable, right? They're not supposed to change. So you have all this like fancy technology and all this this sort of technical debt and overhead to support that fancy technology, but it doesn't really have much use in the cloud. So that was something we really noticed. Like, if we were designing from like way back, and containers was the thing, how would we do it? And I think we go about it totally differently. And then kind of going back to that first point I made about Java, and why use another language or whatever. So there is this perception that Java is slow, and it's not. Java is actually really fast. It's just about using technology in a way that is designed for your use cases. So that's the birth of Quarkus. There's a bunch of other stuff I could throw in there too, like we thought we wanted to get out of the way of the developer as much as possible. So a lot of cool ideas that we had on the back burner, being able to edit your application live, like we made that we were able to make that happen, and then it was kind of like one benefit would just feed into the next one. So it was like, oh great, we have instantaneous start. Hey, now we can do crazy stuff, like we could just blow away the whole app and bring it back again, and then any change you can make live can actually happen. So that was our process that that led us to Quarkus.
Hey, we've got two questions. One is from Tokyo Walker. He says, hey, is Quarkus beneficial for big microservices, like microservice making external calls plus database updates?
So should I answer? Should I take this one?
Oh yeah. Well, you're the
we're just
the boilerplate people here, so you're the one talking.
We just back up.
Oh, okay. Yeah. Okay. Well, awesome question. So actually, Quarkus is really great for. You could use it for all the way from microservices to even monolith use cases. But I will say that we need to have a direction, because you don't want to have a framework that just kind of looks like a big mishmash of conflicting things. So our guiding principle is about microservice development, and while microservices is all about decoupling, you don't want to take it too far. You don't want to have like a million microservices for one application that you just have one team of people working on. So if your needs kind of fit, I really need to do two outbound connections and manage those directly from one calling source. That's totally fine and totally reasonable. However, just because I'm sure one of you guys is going to keep me honest, we do have some limitations that we are working on improving. So like one of the big ones is right now we currently have one persistence unit, because that's the ideal microservice case. You're working with one database. We do support multiple.
You're talking about JPA here, right? Yeah.
Yeah, for JPA. If you're using JDBC, you can do as many as you want. This is something that we have on the roadmap. In fact, you look at the roadmap, 1.8 is what we have it scheduled right now. We're going to fix it, and it's just a matter of interest. Right now, most of our interest has been on more sort of classic microservice paradigm. We do have a few people who are interested in like bringing back the monolith and Maxim. So,
but back to Tokyo's question is like a few external calls and a DB update. I don't even see it as even a big microservice, right? And at the core of Quarkus is a reactive engine, and assuming you can do those calls and DB updates in a reactive fashion, you will actually consume very little resource. We'll just receive the operation, hand it over, doing some NIO, wait without blocking a thread, and come back and then do your database updates and then come back and off with very few resource usage. So that's actually a perfect use case for Quarkus. There was another question from Emmanuel B. Is like, why is Jason wearing a shirt? Is he a manager?
You mean like I should be completely shirtless? Because I'm not sure the audience would appreciate it.
I don't think we want to go that far.
No.
Good question from Jan. What framework inspired Quarkus, except obvious Spring and Ruby on Rails?
I would say it wasn't so much as maybe you guys have a different opinion on this one. We really didn't have a major source of inspiration other than we had a bunch of, like for example, we had some interesting technology in Wildfly. We had some really great technology in Vertex. So Emmanuel's just talking about all the awesome reactive stuff you could use. I don't know if you guys are familiar with Vertex, but it is an awesome project for doing reactive programming. It makes reactive a lot easier than if you use regular non-blocking frameworks, it can get really complicated. And it's built on top of Netty, which is the de facto non-blocking I/O implementation. And then within Quarkus, we made that. We just made it better. So we have this whole notion of mutiny, which I'm sure we'll talk about later, which makes that great. And the whole point I'm getting at is we had lots of great frameworks, but you had to pick, like, okay, am I going to write a reactive application? Okay, then I'm going to use Vertex. Am I going to write like more of a JAX-RS? I want to do some REST, kind of like, because I'm familiar. I know some of the Java EE APIs. I want to use that approach. Okay, well then I'm going to go and use Wildfly, for example. Maybe you're a Spring Boot user, you really love the Spring Boot APIs, well, then you would use Spring Boot. But then if you had a use case that ever crossed any of these things, it just felt like you had to, you were forced into a platform. So we just kind of looked at, and one of the things we love to do is sort of kind of rethink the world and what if we could have our cake and eat it too? What if we could do all of these things? So I would say there's ingredients of lots of different frameworks and patterns that we just pulled into one thing. And then once you do that, this one cohesive thing, then it kind of leads you to the next level or the next evolution, for framework technology.
And I said it one.
Seems like everyone wants to say something.
Yeah, just one thing I'll add. A few things I'll add. If we were to pick inspirations of sort, Thorntail was a massive experience feedback, as well as some piece of code, like all of the the spin-off of what became Microprofile also came from that effort. So that's been a big inspiration. The fact that all of the optimization we've done on Wi-Fi, when we realized that the big initial memory usage came from essentially class metadata, plus GraalVM coming and say, oh, I'm going to erase class metadata, that was a big click for us. Right? So that also accelerated the POC that became then later Quarkus. We had, Jan mentioned Ruby on Rails, but in practice, what we had is at least one person in the team really fan of Play One, which was inspired by Ruby on Rails, but for the Java world, and we've stolen a few ideas from there, definitely. Any other that I missed? There is a shit ton. It's always based on whatever was there before, anyways, right? So.
Yes, the one I said I've heard mentioned the most was Play, right? That's the way they did things.
That's for the user experience. Play for the user experience is still an inspiration, because we're not there to. In some areas, we're still not there.
Yeah.
Apart from all the inspiration, though, the way I see it as someone that was not part of the initial team, the way I see it is a framework like Quarkus could only come from a company like Red Hat, right? Because you have investment in so many different areas. You have investment in Java EE APIs. You have investment in reactive technology, in persistence technology. So all this stuff, in order to come together in a modern way, in a cloud native way, which again Red Hat has all this experience with OpenShift. To me, that was the only way a framework of this magnitude of broad depth and breadth could come into being.
Oh, but by the way, we forgot the elephant in the room. But of course, Spring Boot has been an inspiration as far as we're gonna be opinionated, but you're gonna love it because it's gonna make you, quite more productive. So we definitely also took that aspect. That was also Play's case, right? But Play and Spring Boot really showed that the market was wanting a solution like that, right? And to Giorgio's point is that we to make the fast startup time and the low memory usage that Jason mentioned, we had to really make some core technology underneath, like change, like Hibernate and JDBC drivers and REST server and so on. And that is undoable by a small company. Indeed, it has to have a company that has not just integration, but has the deep knowledge and the engineers that are working on all of those pieces of technology.
Yeah, because one thing that's really interesting about the Play example is I still never understood why they jumped so heavily into Scala. So that's one thing for Quarkus. We support 2 languages, Java and Kotlin, but really Java is really the heart of what we do, and you could be sure that we're not going to do something like that. We're not going to be like, oh, we're not doing Java anymore. We're use this other language over here. That Quarkus is all about Java. So we say kube native Java. That is literally the two huge pieces, Java and running great on Kubernetes.
Well, the one thing we do want to do is move to Java 11, at least, but that might be.
Yeah.
So one more question, and then probably let's go back to the 2 theme of fundamentals, and then maybe dive and keep going on keep bringing the questions, right? So one is saying, is it possible to connect multiple AMQP connections? Example, RabbitMQ. So it is. Well, it's a bug if we cannot connect multiple AMQP to multiple AMQP servers. RabbitMQ has an asterisk associated to it because RabbitMQ supports the AMQ 0.9 plus RabbitThing protocol. So it's not quite AMQ 1.0 and the standard that people adopted since then. However, there is a like a compatibility flag when you run RabbitMQ, and we've seen people using RabbitMQ with success. So again, a bit of a limitation potentially here. We would love for somebody in the community to come and say, I'm going to write a reactive, macro-profile reactive messaging framework, connector for RabbitMQ that would solve that problem. All right, Jason, fundamentals. What are those?
Fundamentals. Right. So I promised, I would not bring any slides. I was like, hey, you guys, I'll get working on a slide deck.
No slide deck.
I can't remember if it was Max or Vaniel was like, we don't do slides.
Yeah, because Jason was like, I need to write this. Like, what about this? Like, okay, you can do demos, but no slide deck.
Yeah, and so in the Corpus style things, you typically it's like you have a constraint, and then you just blow right past it, right? So I've got some old school slides here.
Bastard.
So I guess the first big principle that we have, which is so when we say principle, we're talking about things that we think about as we're developing Quarkus, or if you're contributing to Quarkus, you're writing an extension for Quarkus. These are the principles that really sort of set the direction for where we're going. And like one of the best ones is that we keep footprint low. So what I mean by that is density matters a lot in the cloud, right? So if you have, if you deploy something on Kubernetes, it's not like the case where you have, say, 2 processes that are running. You tend to have something like, 30, 40, 50, 100, right? And all those instances add up and use massive amounts of memory combined in total. So the goal is to have each instance be, as tiny as possible. And the other thing I mentioned before was I was talking about immutability, right? So the instances which serve, either you're acting as, say, a REST service, or you're acting as a messaging, pulling messages and sending messages or something like that. When you write these endpoints, that portion is supposed to be immutable where you don't have local persistent state. So the idea is you decouple your monolith application to where you have a set of these services that are at the endpoints, and then you have another set of services that are your state. Once you do that, the problem is you can't have 1 gig memory footprints for those lightweight services, because the whole value is that Kubernetes can kill them when it wants to, and it can scale up. So, suddenly, say it's like Black Friday in the US and you have a huge spike of traffic. Well, no problem, Kube can scale up 100 instances unless they all take a gig, and then your host doesn't have any more memory available. And then, of course, it can scale it all back down to 0. So a fundamental guiding principle for, within Quarkus itself is that we try to keep memory usage as small as possible. One example of that is that we highly optimize the code for the build time environment. So normally, like classic systems you use, like say an application server, what happens is literally all the code to analyze your application and all the code to run your application is all in the same thing when it deploys, because it has to be able to, the server's running, and then you give it a jar, and then it's got to load the jar. So there's all this work and processing and libraries. Like even if you just look at Maven dependencies, you could find something like, say, 100 libraries which are only used for this deployment logic processing thing. So fundamentally, what we do in Quarkus is we cut that in half. So we just have the deployment happens in build when you build your application, and then you get a jar or you get an native executable, and then you could just run that, and the only thing that's in that is the content of what's ran. So that's the I'll use my another annoying card here of use only what you need, right? So that's the thing. So that's the fundamental part of Quarkus. If anybody asks, like, why is Quarkus so much smaller than everybody else, even the other lightweight frameworks? It's because that's our philosophy. Is it critical for that runtime process? If the answer is no, then we don't do it. And then we're kind of annoying. So sorry if you're contributing a patch to Quarkus and we're like, hey, we'll help you at everything. But we try to keep our memory usage as low as possible. Yeah. So
here's an example. Some people say, hey, can I auto update the configuration? It looks simple, like sure, you can just get a new property being read and then off you go. But it's not as simple as that. You need some sort of an event system that says, hey, this property has changed. And more fundamentally, the framework, whatever is consuming that change, has to figure out, okay, what does that mean? Do I need to restart myself? There's lots of complexity in there. I forgot the details of the conversation, but so far, each time we went into those conversations, the end result was like, let's keep the configuration as it is and not having, magically auto-updatable. And that's a good thing, right? It's not like because we can't, it's like, it's a good thing.
Yeah, which, if you look back at classic Java, right, I think it's one of the things they used to do challenge themselves with was anytime they had a major feature, they had to have 3 separate independent use cases. And that's the kind of thing that we do as well as we're totally in favor of features as long as we always think about the price of those features. So like you can have it as an extension, and if it's optional, then that makes it a little bit easier because then people who want it can have it, and people who don't have to incur the cost. So it's really just about trying to keep everything as lean and slim as possible, and that's how we get those great times. I know I'm kind of going on for a while on this, but one thing I do want to mention that's really interesting from a technical perspective is that producing just the stuff you need, that's like the first step, and it's good practice and everything. But then the other bit is on the more, the core technology of native compilation. The way native compilation is able to produce amazing sizes is by determining the bits and pieces of your app, which are not actually used even when they get included. So a lot of it is it's not just about cutting things out. It's about giving enough information to the native compiler so that it can decide, oh, this branch of code's not used. So a fundamental question I ask people is, okay, you use an API, say JPA, Hibernate, what percentage of that API are you actually using, right? In any given application. Maybe in all your applications you use 100%, but any given application you might only use 30% of the API. So that means you got 70% of it, all that complexity of code taking up space in your actual process that doesn't need to be there. So with Quarkus, we try to strip that out. So when we write extensions, there's a whole mechanism by which you specify that stuff, and with substitutions and influencing what code's generated, and that's how we go back to that theme of using only what you need.
Okay, let's do a break with a couple of questions. The first one is not a question so much as a remark or plea. Alexander is saying, as an active Play One user, please don't get too opinionated. one falls short of quite badly in regards to a lot of the opinionated decision they took. So keep with industry convention. And I think it's tied to, what is it? Hold on. Oh, I'm losing my, there you go. Another, which this one is the question, is Quarkus following things like Jakarta EE? And I think they are actually tied together, those questions. So, I'm making my editorial choice here and then throwing Jason under the bus.
So as to opinionated, completely agree. And this is kind of a balance question that we have to constantly look at, because we want a big ecosystem. We want people to be able to take advantage of this technology in different applications, right? But at the same time, we also don't want it to look like, I just want to write a REST service, and then you look at a guy and there's like 17 frameworks, and then you're not sure, well, can framework A be used with framework C? And so we want it to be like as streamlined as possible for your use case, and then from that we have very strong opinions. And if to tell you the truth, sometimes I wondered, I hope we don't push people away sometimes just because we're like, we say like, hey, when you're writing a microservice, you should only have, this particular style of development.
Yeah. Well, that sucks. We'll never support it, something like that.
Exactly, right. Yeah. So yeah, that's
by the way,
like,
we never said that, but we try to say it rather, you can write your extension, but that probably won't be part of, the promoted pieces that we push, because that's not within the mantra we described before around smallness, microservice, focused externalization, etc., 12-factor applications, things like that.
Exactly. Yeah. So if you connect that to the next question, which was about Jakarta EE. So that's kind of a misconception, because so we do have some APIs in Quarkus that like JAX-RS, for example, to write REST applications. But we're not a Jakarta EE implementation. We're not even really a like we implement the microprofile, all the microprofile specs as extensions. You pick the ones that you want. It's with Quarkus, everything's a la carte, right? You pick the things that are really, they're really important, and you get a meal that you really like, as opposed to, having this, eat a bunch of stuff you're not interested in. So that's so from the Jakarta EE, there's technologies in there that we don't see as having too much of a future. And they themselves are saying that they're moving beyond. Classic example is Java serialization has some interesting use cases, but it is a source of security issues across the industry. So while you can use serialization within Quarkus, we try to go pretty far to push you away from it. So we have technology integrations for things like gRPC, preferring open interop protocols like REST, or using common de facto standards like Kafka. These are the ways in which your components in microservices should communicate, versus say I'm going to do RMI, right, which can quickly turn into a big mess. And it's also really hard to optimize as well, because all these protocols and these technologies are based on this idea that, well, I don't know what I'm going to use, so I just need to keep it all, I need to pack up my entire house when I go on vacation, because I might need some random thing and I'm not really sure about it, So
I don't know what you're talking about.
You get out of the airport, Emmanuel, do you have like seven gigantic briefcases or something like that?
Yeah, exactly. It's like my porters are. It's like, what do you mean two luggage? Two luggages. By the way, I don't have a porter. I usually carry them myself, just to be clear. Okay, next principle that we use.
Sure. By the way, I can't see the output. Is it there?
The output of you should be able to see.
Oh, now.
Yeah. You see yourself, okay. But that's because that's the output.
Sorry. Anyway.
All right.
Okay, so slides.
Yeah, I got another slide here for it. It's not a slide. So devs should love it. This is something we struggle with, right? We have lots of great. Actually, I should probably do higher because my name's probably not there. Basically, 1 second, guys. I'm gonna disappear.
Don't worry.
Okay.
What can we do?
Sorry, lost an AirPod. Okay, so anyway, yeah, this is the stuff, the fun of live shows, right? Anyway,
actually, that's the first time for us. It's like, hey, I'm losing my headset. Don't worry, I'm just getting it.
Yeah. So what I was dev shell of it. So basically, if we've had a lot of features which are like, man, this is the most amazing technical cool thing you could do. It's only a 20-step process, and if you just look first, you build your application, and then you look at it in a disassembler, and then you look at the different values, and then you feed that into a configuration file, and then man, you get the best, most finely tuned, awesome performing application ever.
And to be fair, Red Hat teams have been the master of that for the longest time. So Quarkus internally for us was really a call to action to focus on not saying that. Like in theory, if you apply all of those, you'll blow it out. But in practice, people don't have time to learn those 20 steps process multiplied by the number of frameworks, right?
Yeah, and the really scary thing too is that we over time with that much complexity, you tend to forget that kind of stuff as well. So then you read all this cool features, then months come by, and then you're shipping, and then people are like, hey, I've got this performance problem, and then you're like, okay, how do I use this again? So basically what we do is a feature may be great, but if it's not something that is going to be fun for a developer to use, or it's going to be painful, then we throw it to the side. We're not going to do it, or we rethink it. And what surprises ourselves is we keep thinking like, oh, there's no way you could make this easy, but then we come with another crazy idea.
An example is with configurations. Oh, there is no way you can survive with only those 2 configurations. So we ship it with that.
Yeah.
And then nobody asks for a third one.
Times. Yeah.
Exactly. Well, so we're aggressive in the simplification, and then we step back if we went too far.
Absolutely. Yeah. And there's like many cases like this where, I mean, for example, one of the features that we're really proud of is the live edits, live coding capability in Quarkus, right? So you pull up your application, you could change whatever you want, and then it just happens. At first, the very first versions, we didn't support editing POM files because it was kind of like really tricky on how we're going to get that to be right, and how is it going to work when the person hits the request, and it might make the page load slower. So we're like, well, we're just not going to address that use case until we figure it out, and then there's a much better solution in place where we have essentially we have 2 strategies. So we ended up with a better result. So that's the first thing. And actually, I should say we're very reliant on feedback. So even if you send us a message or whatever, and you're like, this sucks, we actually love that feedback. Once you get over the hurt feelings thing, there's oftentimes something there, where that experience leads to, okay, we need to rethink how we're doing stuff. And I'm not saying we're perfect or anything, but we try really hard to make sure that developer loves it. So if you're contributing extension to Quarkus, you might get some usability feedback on stuff like that.
And like Jason says, oh, sorry.
No, go ahead, Georgia.
Like Jason said, a lot of this stuff comes organically, right? So there's a lot of stuff that you can't address up front, like the whole thing. Something you just have to get the basics right and get the rest get it implemented by user feedback and by dogfooding yourself, right? Because we have a lot of people inside Red Hat using Quarkus themselves that also provide great feedback and help us improve.
Yeah, and it's the challenge we have is you get that feedback, and then the easy path is to just add the feature, right? And you keep adding, and then you look back 3 years from now and you failed again, or you have a slow Quarkus. But because live reload does rely on the fast startup of Quarkus, it keeps us honest, but we need to constantly fight back. Do we really need that feature? Compared to the main use, the 80%, 90%, 95% usage, what does that bring? What's the cost of that feature? And we put a tight rope on those compared to other frameworks.
I'm still waiting for my stateless injection stateless entity manager injection.
Hey, Alexander has a question. It's like, is there a danger of Quarkus being jack of all trades and master of none? By the way, I heard Master of None is a great series, but I haven't watched it yet.
Yes, that is a danger. It's something we are. I mean, this kind of relates back to the other question about opinionated platforms, right? So we're thinking really hard about this, and we kind of look to you guys in the community to let us know how we're doing in that area. The way I like to think about it is we want Quarkus to really reflect developing microservices on Kube. That's our primary target. We have some other cool use cases that we want to support. And additionally, we want to be a foundation technology that others can take advantage of. So we have, in the Quarkus ecosystem, we have the notion of a Quarkus platform, and it's all the extensions that we have that's built right in. But we're not limited to just that. We also have other communities which have written extensions for Quarkus, and we want that to continue. Even if somebody, for example, says, you know what, I really want to use Quarkus for Corba. Okay, well, that won't be in our main, our main platform because it's not the direction that we've picked. But we definitely want to enable that use case. So if someone wants to form a community around hyper-optimized Corba usage and they want to use Quarkus as a foundation technology for that, great. We love that. That's awesome. So that's kind of how I see it. And you guys let me know how you think about it.
Yeah, so to be honest, we did struggle into organizing that ecosystem because so many stuff happened in parallel at the same time that it took us a while to organize that ecosystem into the platform, the ecosystem at large. But we're not there yet, but we're getting there, and we'll try to, until we're ready to take a handhold manual approach to discussing with the various contributors and say, okay, it's going to be there, it's going to be not. Sometimes we do make mistakes, but we knew the day one, we knew we couldn't make a good omelette without breaking eggs because we do a release every month, so there's got to be some mistakes, but the idea is to fix quickly.
So in 1.7 is actually the first step, because this whole platform idea we have is right now limited by we only have one platform, and that means there's stuff we haven't included that's easy to get access to. So one is, for example, there is who did GSF support for Corpus. I think it's the MyFaces guys, right? That is one we know we would not put in the platform, but it's one of those things where it'd be really cool to have it because there's a lot of people who actually use GSF with a light backend. And so we didn't have an answer for that. But in 1.7, which is master right now, we have a feature called the registry, where you can actually add these things that are outside the platform but done by others, so that they'll be available in Quarkus add, Quarkus lists, those kind of thing. So yeah, it's coming. It's called if you want to look in Jira, not in Jira, look in GitHub for registry. There's a feature that'll be in 1.7, and we'll see if we can get it final. But if not in 1.7, in 1.8, it's the idea to have that enabled.
Okay. So 20 more minutes. So how many principles do you still have, Jason?
I've got a few more, but we don't have to get through. But I got a fun one I could throw out, which is all about we don't really like boilerplate.
A little higher, Jason.
A little higher.
There we go. Oh yeah.
No boilerplate.
Okay. Yeah. So I guess put it another way, we say less, get more, right? So it's really interesting because we spend a lot of time, we talk about Quarkus is so fast and you could do all these APIs and so on. Sometimes we don't talk about the stuff we do on the API side, which is one of the feedbacks we get from people who've really liked Quarkus. Is they're like, man, I actually had to write like a third of the code that I used to have to write. So it's something as simple as you write an application and you want to have a REST endpoint. You just write one class that's your resource, and that's it. Like there's no application wrapping class. There's no deployment. There's no XML. There's no YAML. You just have your properties file and you have your single class your resource. And we've tried to carry that throughout the whole thing. So, even if this means that we have to do things that's beyond what, say, a spec might say, so, they may say, oh, you're supposed to have web.xml, how dare you? It's like, well, sorry. What we've heard from developers is they actually prefer to not have to write a bunch of stuff. And then not just that, like cutting stuff out, there's also, we mentioned Mutiny earlier. Mutiny is really cool from the reactive standpoint because, if you just look at what it takes to write a reactive system and you compare, this is my code in Mutiny and this is my code, in a typical reactive style, it's literally like 1/3 of the code that you write, and the names actually make sense and map to each other. So that's kind of a common thing.
Yeah,
and this is another thing.
So much less code, but it means something. That's the objective anyway. That's the principal objective is readable code.
Yeah, well, it's readable and it's concise, right? And the chaining is done in the right style, right? So you can move between the different paradigms, that's what I'm getting at with the duplication. In sort of classic frameworks, it's okay, then you have to write all this thing, and then boom, I need this other type, but it doesn't actually map. So now I got to write this converter thing, and then I got to write the converter thing, and then map the converter back to my reactive chain sequence. So Panache would be another great example. So you could just write your queries in a certain pattern, and it uses significantly less code than if you were to develop a straight JPA QL sort of standard approach, build your entities, build a resource class, and then have utility classes which then operate off of that. Instead, that's all just one straight mix.
And another thing that I think we don't maybe emphasize enough because at this point it's self-evident, but at the beginning, I don't think you guys can correct me if I'm wrong, but I don't think the single configuration file thing, I don't think was a thing that oh yeah, this has got to be the way to do it. But it turns out that it is so powerful to have everything driven from one configuration file and have proper configuration, proper nesting of the configuration objects. To me, that makes things so much simpler from a user perspective. I mean, I was used to that sort of because from Spring Boot, but when I was in previous jobs, whenever I have to do Java E stuff, and I seeing this web XML stuff and this persistence XML stuff, I'm oh, I don't want this at all. I just want application properties and let me configure everything there.
Yeah, did you just love it when you pull up your IDE and then you look at your web XML or your persist XML, and then you get all the red lines all over the place because
that was perfect.
Where do I find the schema files for Java EE? Blah blah.
That was the worst. I mean, I could never deal with that. Or even with the Spring, same thing for Spring, right? When Spring used XML, you had the XML schemas, and IntelliJ was complaining I couldn't find version 4.1. I have version 4.2 or whatever. That was a nightmare, at least for me. Yeah, it was
that's a failure of using it correctly, would someone say. But that's back to the...
Yeah, sure, but I didn't want to have to learn how to use it correctly. I just wanted one properties file, and then with my IDE auto-configuring everything, it just makes things great.
It's a good example of what Manon talked about. It's XML has some great features, validation and schemas and all that stuff, but everyone who actually used it in the industry, whether it's Java EE or Spring Boot or whatever, they did it wrong. They didn't follow the right procedure. And there is one, but it's just too late because everyone done it wrong the last n number of years. But
but when everyone it turns out doing something wrong, doesn't that mean okay, there is something fundamentally wrong?
That is true.
Okay, so one quick nasty question, and then probably the next principle. Okay, so Vinicius is asking, who came first, Quarkus or Micronaut? Micronaut with Oracle will be the main competitor. Aha.
So do I get this one, or
I can start.
Yeah. Okay.
So Micronaut, was started about a year before Quarkus, something like that. No, I forgot the timing, the exact timing. It was started before, but what Quarkus is and was from the very first line of code is designed to handle native compilation and optimize for native compilation. And that doesn't mean removing reflection. It really means moving as much of the configuration and build time effort startup time effort at build time, and have as less as possible at runtime, so that the code base is simpler to analyze and the native image is smaller. It turns out that when you do lots of things at build time, you can pass the right information to GraalVM, which means then the compilation is just the one line versus a complex process of, some people have done manual complex application and make it compile in GraalVM, and that they have done it once. Right, it's a complex process. So here in Quarkus, it's the guarantees, like the whole ecosystem runs with native image compilation with GraalVM, and that's a big difference. Otherwise, the two communities started in parallel. The concepts are similar. The concepts are somewhat similar. Try to shift as much at build time as possible. So both are going in the right direction on that.
Oracle, I think the thing.
I'm sorry. Go ahead.
No. You finish your thought. I'll jump in.
Well, as far as Oracle, look, guys. I'm seeing a lot of comments around. Hey, it works great and better than Spring Boot, and what is the difference with Micronauts? In practice, yes, we do look at the competition, and we tend to be paranoid, like anybody. But we try to focus on the value add. So our value is not so much, hey, we're better than these guys on that benchmark or whatever. We try to look at the bigger picture and the value we're bringing to the users, right? And hope this will just make the difference.
Yeah. So I was just going to pick. Yeah, I was just going to pick up on the thing you mentioned about native compilation ecosystem. So a lot of frameworks that are out there, and there's certainly been a variety of frameworks that come about and are like lightweight. So we mentioned Play, right, which was around ages ago. A big difference is that a lot of these frameworks picked a particular direction, and then they transitioned to be compatible with native compilation. Whereas with Quarkus itself, we really designed the whole thing from the beginning to favor native compilation, and that was because we were really focused towards running well on Kubernetes in the cloud. So we were actually when we think of competitors, we were actually concerned with the possibility of developers leaving Java, which was such a productive environment for them. So we were concerned about developers leaving Java for technologies like Go. So a lot of our thinking was, can we bring some of that optimized experience that you can get with these more native-centric frameworks and bring that with the productivity of Java? And that's been our mindset. It's, it hasn't been as much about like with framework Z over there and can we build our own framework Z? That's not what we're doing.
One quick question, and maybe the next principle. Sux94 is, I always forget whether 94 is some part of your zip code or when you were born, but sometimes I see, whatever 2002, and I'm like getting depressed. So should we use Hibernate in Quarkus without Panache? What is your opinion about that? So first of all, Panache is just a layer on top of Hibernate. So you can use Panache and Hibernate. You can use Panache and do an app inject entity manager and use Hibernate, the JPA APIs. That will work great. So use it for, our recommendation is go with Panache because it will probably keep your code simple for all, say 80-90% of your usage. But when you feel that Panache doesn't have the feature you want, so maybe it's obvious and it needs to be added to the API, or it's fine just to add inject and use the entity manager for that one or those 5 use cases in your applications, right? Those 5%. So start with Panache, and when you see the limit, go for the rest. Yeah, go ahead, Max.
And I have to add that, so I fully agree with you. Like, I think Panache simplifies a lot of things. It's just a layer on top of Hibernate. You can just use it. And something that I know George and me is trying to just find time to preach everywhere we can is that Hibernate also has this thing called stateless entity management. that means you can do like raw queries, whether it's native SQL or stored procedures or HQL or JPQL. You can do that, and you can get back unmanaged entities, which is nice for some performance cases. Or if you are just doing some batch operations or some basic reporting, you don't even need to have entities. You can just do like basic attributes or PTOs. Not PTOs, DTOs. Yeah.
That is me at the end of the week.
Max is already thinking about vacation.
People that don't know PTOs means, what is it? Personal time off?
Pay time off, whatever.
It's both, I think.
And personal, yeah.
Yeah. So, so anyway, so my point is that one of the few times that when I present Quarkus, people always compare this to like, I want to use MyBetas or Spring JPA or Spring JDBC and that kind of thing. And I go look at what they're using, and they're literally using what looks like the API that's in Hibernate already. People are just not aware of it because we've talked about Hibernate for entity management for so long. But Hibernate actually has a very efficient and simple stateless query mechanism.
Yeah, but you and I both saw it last time we went looking for the docs. We couldn't really find it. Right?
That's the thing. We need to write the docs. They're undocumented. They're under-documented.
Yeah.
So yeah.
All right. Next principle.
Okay, so we don't have enough time for two. One of them we already talked about. So reactive for mortals. We're probably not going to go with that one because we've kind of talked about mutiny.
Yeah. Plus
already.
We had 2 episodes with Clément, so we're like reactive.
Oh, okay. So everybody's an expert at reactive programming.
Exactly.
Awesome. You guys can give me a hand. So this one, which is probably how if you listened, if you actually stuck with this and you listened to the whole conversation, is probably what it sounded like. You know, it's Kubi Koob.
It's like the Swedish chef.
So does that mean I cannot run on bare metal? Does that mean I cannot run on the Pi? You know.
Yeah, you can run on bare metal. We actually care that it runs well on bare metal. Coincidentally, if you run really well on Kube, you will run really well on bare metal because one is a much more constrained environment than the other one. Although to be fair, there are some things like ergonomics when it comes to performance. You know, like we tend to favor automatic defaults for container environments. So if you're running on bare metal, you might have to do some extra tuning. Because we're just not assuming that you have a 64 gigabyte heap with 300 CPUs or anything like that, right? Like we're assuming that you've got 4 cores and you've got about 500 megs to a gig of memory at most in your container environment. And then our target footprint, if you look at our website, for example, and you look at our examples and quick starts and where you write your own application, you experience yourself, we're in the tens of megs. Right, so you should see tens of megs memory footprint if you're running either a native or in JVM mode. Depending on what you're using JVM mode, it might get a little bit higher than that because JVM has a certain base footprint.
By the way, it's we're essentially confident on the bare metal big heap size because we're reusing libraries that we've been optimizing for like 10 years or even more sometimes via the effort around Wildfly. So we're very confident of our throughput, and high memory usage. High performance usage in high memory systems or in the bare metal systems. That's why we focus on Cube because we know that's where essentially no Java frameworks have really made an effort until then.
Yeah, and one thing I meant to say is, so when we talk about Kube, it's not just about performance. We're on a journey to make the integration with Kube as tight and as pain-free as possible. So we know many of you are really used to bare metal and are kind of looking at some of the cloud technologies, Kubernetes and so on, and maybe aren't ready to start moving your apps over to it quite yet. And what we would like is for that experience to be, you don't even have to think about it. Your team can just pick up the technology and say, oh, I built my Quarkus app. Now I need to get on Kubernetes. I just pointed at the Kubernetes instance, and then I get my application. And so
we have some around Quarkus deploy, which is going to be a new verb that is going to impersonate that to some extent. It's like just go deploy, and we figure out the rest based on the configuration you've done. Sorry, I cut you.
Yeah, exactly. Yeah. Oh, no, that's cool. So yeah, so today we have the Kubernetes extension I was going to mention that you can use, and it does basically that. But we're like, as you're just saying, Emmanuel, we're going to take it to the next level. Because like ideally, like I said, you shouldn't have to. I always feel like when you try to build an application, with all modern technology today, it's like you have to have like 30 books. It's like I gotta stop. I gotta read like. I have to spend a month learn this technology, then I got to spend another month, and I got to learn this other technology, and then finally you're ready to combine them together, and nobody writes how you do that. Like everybody just writes about the one thing. So we're really trying hard to make the framework do a lot of the heavy lifting for you, so that you don't have to be a Kubernetes expert. You could actually deploy your application in your local instance and test it out, and make sure it works okay, and then. Then when you get closer to ops, maybe by then you've had enough time to dig into it more and understand all the intricacies of how you manage your pods.
But there is an aspect of ops, right? When we say Quarkus is kube native, that part came a lot from the small Y implementations of some of the microprofile specs. But metrics, health systems, they're absolutely. Tracing, all of those are absolutely mandatory in a universe where you're splitting your app into many pieces, and where a platform is actually going to handle the load, and when an app is down, going back up for you, is that it needs some input from your application, and that could be metrics, that could be, am I alive? Are you okay? It's like, hey, are you okay? It's like, oh, he's not answering after 20 seconds. I'm just gonna shoot him in the head and restart him. Which works for apps, not for humans. So don't try at home. But these are important aspects that were right there from the start. And if you feel there is needs for us to improve that's also a key aspect we want to.
Just give an example of how all this kind of fits together. Which like this wasn't here a year ago, but now it is. It's like you start with your example Quarkus app. You start writing your code. You add in just the what's it called, the small Y for the metrics, and if you start deploying it, not only will we automatically set up those health checks in the deployment, but if you deploy it to OpenShift, I'm not sure if this is in 1.7 or 1.6, but it will add in the right resources to actually show up in the OpenShift monitoring setup, right? So which you can't do on Kubernetes because they don't have them by default. But the idea is that we can kind of we know enough to make it so you don't have to deal with all this setup. You just need to know, I need to have a health check because otherwise, things are bad.
Yes.
And then everything is.
If you're in the 5% case where you want to customize that, then we got the fallback situation.
Yeah.
Yes.
Knock yourself out.
Exactly.
Yeah.
There's always the edit YAML option.
Yeah. And to give some numbers on that, like to do a health check, it's literally like you've got one class and you have a method you implement to write your actual health capability, right? It's not, this isn't like complicated stuff at all. So you could really, like, I think our whole idea is that you've got like maybe, I don't know, like half hour to hour break during your day. You could just take Quarkus and start rocking out some Kubernetes stuff. So I wouldn't say we're fully have all the pieces completely there, but I think if you were to try and walk through some of our demos, you'll see, hey, this is actually pretty easy to get going and really have a compelling solution that you can use.
Well, we should probably do a demo here with all that stuff, right?
Yeah, we actually have the most, at least last time I looked, the most wanted session actually Kubernetes and deployment. Okay. So we should put that on the schedule.
Yeah, I can do that if you want. Either me or you want, that'd be cool.
Well, both of you.
Yeah. Get both of you.
Jason, sure. Maybe closing thoughts because we're 4 minutes late.
Yeah. So I just wanted to say I hope that this discussion was was useful to you to understand kind of where we're going with the project. It's kind of really just the start of the conversation. Really what makes Quarkus successful is all of you using it, and we've been blown away at the amount of contributions, the number of contributors that we have. So please get involved, even if you're unsure. Like
you need more. You just
more
said you had more than you
contribution,
needed.
more stars, more comment on Quarkus dev, more
Yes.
+1
star.
on issues. More everything.
More everything.
Yeah, and then your honest feedback is obviously welcome on this, and yeah, let us know if this kind of topic was useful. I know it was a little bit less demo centric that we've done in the past. Our thinking was kind of give a bit of the background, and I hope you enjoyed it.
By the way, another way to help is go to Stack Overflow, find a question, answer it, or if you don't know the answer, look in the guides, and if it's not in the guide, then open an issue or start a conversation to then add that section in the guides. That's actually, helping people stuck on a problem is a key part of this developer joy that Jason was mentioning, and we've said Stack Overflow is the standard way to get answers for those. So just go at it. Yeah. All right. Well, that was a good session. See you next week on MongoDB. With Panache.
MongoDB Panache.
Reactive everything with Loic. One of those massive contributors. And in the meantime, have a great week. And don't forget to check out youtube.com/Quarkus.io, subscribe, do whatever you need to be there next time. Bye, everyone.
See you all.
Bye-bye.